Hello, different type of video. I'm walking through university grounds now, so I want to talk. If I may have some of your time, I want to talk about why I want to dispel some fake hype and some marketing hype that's been going around in the past months about LLMs and decision making, and so why is it that LLMs are not able to and never will be able to do decision making by design effectively? Like, they're just unable to. The reason for that is that if you think about it, okay, so I want to explain first of all a bit about how LLMs work. And the way that LLMs work is that you have your input, you have a text, you have a string of characters or of tokens or whatever, and you need to encode that into a vector space. So you pass them through the encoder, and what you do is you don't care just about the token ID, you care about the position. So you have a two type embedding. You have a positional embedding and you have a categorical embedding, I guess you can say, based on what the token ID is. And then that generates a vector space that generates a unique vector inside of a vector space with as many dimensions you want it to have. If I remember correctly, GPT-3 in general had a embedding space of 1024, if I remember correctly. BERT has 768, if I remember. Oh, that's a tennis court. It's theirs. Yeah, and so you have this wild embedding. Oh, this is a nice amphitheater. The fuck? Where am I? Hey, let me. Well, I can turn the camera. Like, it's a real nice place here. Anyway, so you have this embedding that is generated, this vector space that is generated by all of the different vectors, embedding vectors of the strings of the input, and then you need that to get parsed and fed into what is the decoder. You have the encoder that encodes into vectors, and then you have the decoder that decodes into strings, into the next token, in a sense. And the way that you do that is that you have what is called the transformer architecture, which essentially uses what's called as the attention architecture, which is multi-headed self-attention. Essentially means that you have multiple linear layers in parallel, where each layer analyzes a sort of a part of the initial text, and the output of each of those heads, as they are called, is essentially a weight that this ascribes meaning to the tokens. So for example, if you have the word "my cat is sick," etc., 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 and you start talking about your cat, the fact that it's your cat doesn't carry as much significance. So my might not get assigned as high a value after passing all the heads, and so you repeat that. You have each pass through the attention layers, the attention heads is, and a normalization later, but that's whatever. It's called a transformer block, and so you have layers of transformer blocks, and based on that you end up with essentially the transformer architecture, which is just stacks of transformer blocks on top of each other. And so you have that, and then LLMs specifically just have an output layer, or you could have, you'd have mixture of experts, you'd have different architectures rather than just self-attention. But the idea of a transformer block is that you input the embeddings, the vectors, that the vector embeddings, and you output their significance, in a sense, how significant its token or its part of the array of strings is. And then after you have that, you go out and you pass them out to a linear layer at the end, which is the output layer. And so the output layer for LLMs is the space of all tokens. So this is how you can get ChatGPT to say whatever you want, or Anthropic's Claude, or DeepSeek, or whatever. You just have, you enter a string, it passes through, it gets filtered, it gets embedded into a vector space. Then that embedding of the thing, its token separately, gets passed into transformer blocks, which analyze and capture and weigh the different parts of a sentence, a paragraph, a text, whatever. And then based on that analysis that happens inside of the transformer blocks, you have an output of a single token. But the output is a distribution over all tokens. And that's why it's not possible to have decision making, because you are just outputting a distribution over tokens. There are people saying that it's not just a distribution over tokens, but the truth is that it's not just, because the transformer blocks and the self-attention or the mixture of experts or whatever does build a type of semantic understanding. Like, the way that it works is the way that you pre-train a transformer architecture like GPT, is that you have sentences, like let's say this is an apple, and you train it, you give it this word, and that word has an embedding as the encoder has embedded all of your training data into a vector space. So its word in its position has a specific embedding, and then the transformer guesses the next token in training. So it says this, and then might say what, and what is much different from is. So it will be different in the vector space. It will be far away. You can see what's 3 Blue 1 Brown's video on that if you want more information. But the gist is that that will create it will be different enough that you can tell that the AI is far away, and then you calculate the difference, you save the loss generated from that, mean square error or whatever, and then you get the next token, which is this is an, and then it might not generate an, it might generate like a random word like cow, and then it calculates that difference in the vector space using mean square error or whatever loss the researchers, the developer wants. And then if you repeat that enough, what turns out is that when you have this, there is a list of tokens that is good enough to be guessed. And if you only have one token, the word this, then there's many of them. But if you add more words and if you build a prompt that is more specific, the agent is able to, because it has trained on so many different instances of the word this in many different contexts, and so it has learned to sort of understand what it means to say the word this, under which context the word this appears, and can guess what is a probable next token to say. And so it is really distribution over the output tokens, because it just learns what tokens, what is the best token to follow the context before, and that is just a distribution over the output of the LLMs and over the tokens. And so that is truly, literally just an output distribution over the tokens, and that has no inherent decision making, because you're not, like, the way that they prompt them to respond the way that they do is not that they say that you just feed the prompt. Like Claude 4, I think, or Opus 4 or something, had its prompt leaked, which is 10,000 words and tokens, and all of that is just priming the agent in order to guess the next token correctly, and so it just generates a lot of context that the agent can use to guess the next token. And so it's all about literally guessing the next token. There is no decision making in that. But nowadays people are talking about AI agents, and they're talking about how to use multi-agent setups, or how to use OpenAI's ChatGPT for decision making, and what one is the best for decision making, etc. But you have to think that, like, what the agent is doing is that you have the phrase, when you say pick the best framework for me to write my API in, what is actually being prompted to the agent is you are an assistant, an AI assistant called Claude, and you are being asked this by your project manager: what framework should I use for my website, for the front end? And then you, as a helpful AI assistant, respond with the following. You respond with, and then it's just start generating what would a good AI assistant pick. But there is no, it's not a good AI assistant, it's just pretending to be a good AI assistant. It's guessing what a good AI assistant would pick, which is really different from being a good AI assistant, understanding why it should pick the framework. Like, it will pick the framework that it picks just because it's the one that has encountered more often in the training data. So if you say, I would pick React, like if React comes up often as a JavaScript framework, for example, then the AI will learn that React is a good framework to use, not because it's good, not because for its merits, but because it's the one that's the most popular, which is a critique in developers. Don't pick what's the most popular, pick what's most useful for you. But AI cannot do that. By definition of how it is trained, an LLM will never not pick the most popular unless explicitly instructed to. So if you see ChatGPT one day not talking about React, or how their programming feels, how if they're more verbose or not, it's all about what they have been prompted to say and think, not think. They don't have thought, but like what to repeat, what to spew out, if you will. So it's all a distribution of over the tokens. There is no, oh, that's a nice firefly, almost stepped on that. There is no inherent decision making because it's just guessing the next token. But what would be decision making? Decision making in this scenario would be that rather than having an output over the tokens, you have an output over specific actions. So you take the input, you have the exact same mechanism of the transformer layers. So I gave the agent a sentence. The sentence gets parsed and embedded into the vector space, and then these vectors, the embeddings, get fed into the transformer blocks, which continue for how many layers we have, and then the output is not a distribution over the tokens, but it's a distribution over the actions. And that's true decision making. That's reinforcement learning, essentially what it is. But the thing is, with reinforcement learning, you are not able to have the capacity to both pick an action and to generate tokens. So you're really locked into hard coding the functions that you want the AI to have. So MCP goes out of the window, it doesn't exist, because you just have the API and you teach the agent to make the correct API calls, not to describe what an AI agent, a good AI assistant, would perform. And it's really stupid how the Western and the Eastern, I don't know, I'm not American nor Chinese, how they present agents, agentic systems or whatever, because it's like, yes, you will have an AI agent that is able to do your taxes, but it's not really able to do your taxes. It's able to predict what a taxman would say. It's good at that, obviously, but it's not inherent decision making, and it will never not make mistakes or hallucinations or whatever, because hallucinations are not about not bad data or whatever. It's about popular data. If you want to convince yourself a bit more about the non-decision making of AI, you can easily make an MCP server to play chess, right? You have a client, you have just have the MCP client, you have the MCP server, you hook them up and you have the AI play chess against Stockfish or whatever. And you can really see that it struggles not only with the fact that it has, because you have the MCP server, you're essentially constraining the AI to play only legal moves, but that does not mean that the moves make sense or that it understands why it's making these moves. It makes these moves because that's what it has been trained on. It has been trained to, when talking about chess, to produce a letter and a number in chess notation or whatever. And so it maybe has learned that this is the state, blah, blah, blah. It might reason. Reasoning models are no better. They're essentially prompting themselves by saying, there is a training involves them saying, I might be wrong, let me rephrase that, so that it's essentially self-exploring a bit the latent vector space, or however you want to call that, but it's not effectively doing anything more. Am I in the same spot? I might be lost. But yeah, effectively there is no difference in how the LLM there is no actual decision making. It's just guessing, effectively guessing. It might be better than guessing, it might be worse than guessing, depending on the training data, but it cannot learn by playing chess. It cannot improve by playing chess. It cannot learn to be better at chess than it already is, unless you fine-tune it more on chess moves, but not on actually playing chess. You cannot train it to play chess. I think there might be, me and a couple of research associates, colleagues, friends are cooking something, so it might be relevant. But for now, all of the big LLMs, even with reasoning, even with whatever, they're not able to play chess. Yeah, I'm at the same spot. Okay, let's go back. But yeah, there is no inherent reasoning that makes them better at decision making. There is reasoning that makes them better at guessing the next token, but there is no actual decision making at any spot. With reinforcement learning, you can train the agent on playing chess by simply playing chess and self-play. You have AlphaZero beating the best Stockfish of the time easily by self-play, just repeated games against itself. An LLM cannot do that. It cannot learn and self-improve by doing that, unless what we're cooking works. But the inherent fault of LLMs in decision making is always that they can only predict the next token at every step of the way. You give them the state, they just pick the next token. There is no, it doesn't try to be good. It tries to guess what somebody that is good would say, and that's not good. Back in the physics exams that I gave for my bachelor's, or mathematics for my master's, and you went on the blackboard and you just repeated the things you read, that you may pass the class, you may pass the exam, but that does not make you a good mathematician or a good physicist or whatever, which is why I'm not doing physics anymore. I'm not built for that, and that's okay. But LLMs are not built to be decision makers, but because they are pretty good at memorizing what a decision maker would say, they are able to pass as decision makers. But at the end of the day, if you take somebody that just memorized or cheated in all the exams and you put them in an engineering position, you will not get any results. You might get results if you put them in managerial positions, but like you will not get any results if you put them at a novel situation that they haven't been trained for, that they haven't memorized before, and you tell them to just work and do the thing, because they're just going to be like, I remember myself and some other students doing general relative, no, it was differential geometry, horrible professor, but that doesn't matter. We had to give an exam, and it was, you have to prove your own thing as a question in the exam was, write something that you want to write, and other people were proving like the Einstein equations of motion, which like, oh, way out there. And I just remembered the definition of the Christoffel gammas. I wrote that. I didn't get a good mark, but I didn't need to, because like I had memorized how to do that, and I just wanted to pass. Meanwhile, my friends, they didn't memorize how to generate the Einstein equations. They had intuited how to generate, and then they got a much better grade. Now they're not everybody. Some people didn't continue in physics, but like everybody is doing great things. I mean, I feel I'm doing good myself, but like it's just because I didn't continue on that path. Like that was sort of a wake-up call for me. Like, hey buddy, maybe you're not good for that. But LLMs don't get that. They get all the praise in the world just because they can do the Christoffel gamma, which is impressive for a computer. But like it should not, if you can prove the Christoffel gammas, if you're at the level where you can do that, probably you shouldn't become a professor. You shouldn't become a stock handler, unless it's that easy. I haven't really done that. I've done some asset liability management stuff, but with reinforcement learning, so I don't know if that counts. And yeah, it's just like there is no, they just repeat, it's literally just a probability over the outputs. As a friend, and apparently Chomsky, like I think he's a linguist or something, a socialist thinker or whatever, Chomsky, like he said that LLMs are like stochastic parrots, and they truly are, because they're just parroting what they've learned. They say things that have been in their training data, or that are near to their training data vector wise, like they stay close to what they know is good, and then you fine-tune them by paying like dirt wages and exploiting people in Africa, as far as I know, to do the reinforcement from human feedback, because somebody has to do the value function by hand, and it's sure as well hell isn't going to be the San Francisco tech bros or the Chinese that are in good terms with the government. So it's probably going to be Africans or Indians, or people in developing countries that are looking to make some money to provide for themselves and families. That's neither here nor there. We're not here to talk about the ethics. But yeah, the inherent issue of LLMs, once again, I really want to reiterate, is that they cannot make decisions because they do not know how to make decisions. They know only how to say what a decision maker would say, and that's a problem. That's a big problem.